Good morning, dear students. So in last class we were looking at finding the different transformations. So we have seen when the equation is in elliptic and parabolic form, what are the transformations which will help in obtaining the canonical form. Okay. So now we will see for the last case when you have an elliptic equation. So how to find the transformation. So how to find functions u and v. So when s square minus 4rt is less than 0, so when the discriminant is less than 0, that means you will have complex roots. So the equation r lambda square plus s lambda plus t equal to 0 will have complex roots. So let me call it as lambda 1 and lambda 2. Now the characteristic equations are given by dy by dx plus lambda 1 equal to 0 and dy by dx plus lambda 2 equal to 0. Now solve for this equation. So the solution will be of the form. So it will be of the form f1 of xy plus I, f2 of xy equal to c1 and f1 of xy minus I f2 of xy equal to c2. Now here we will choose u equal to f1 plus if2 and v equal to f1 minus if2. And here let me take alpha equal to f1 and beta equal to f2. So now we need to find p, q, r, s and t in terms of alpha and beta, and this will give us the canonical form. So the canonical form will be of this type. So you will get in the form dou square z by dou alpha square plus dou square z by dou beta square equal to phi of alpha beta z, then dou z by dou alpha, dou z by dou beta. So this is going to be your canonical form. So now we will see how to reduce a given equation to the canonical form. So we will see using an example how to obtain the canonical form. So it will give you a better understanding. So the question is reduce to canonical form and hence solve dou square z by dou x square minus dou square z by dou y square equal to 0. Now നമ്മൾ കാനോണിക്കൽ ഫോം ചെയ്യുമ്പോൾ നമുക്ക് കിട്ടുന്ന കാനോണിക്കൽ ഫോം എപ്പോഴും നമുക്ക് സൊല്യൂഷൻ കണ്ടുപിടിക്കാൻ പറ്റണമെന്ന് ഇല്ല. കാരണം we have learned only how to solve equations involving constant coefficients. അപ്പോൾ ആ ഒരു ടൈപ്പ് ആണെങ്കിൽ നമുക്ക് സോൾവ് ചെയ്യാം. So because you are learning only a particular type of equations. അപ്പം reduce ചെയ്യാൻ ആണ് ചോദിച്ചിരിക്കുന്നതെങ്കിൽ reduce to the canonical form. So if you are asked to solve the equation, then only do that, because നമ്മൾ വേറെ മെത്തേഡ്സ് ഒന്നും പഠിച്ചിട്ടില്ല സോൾവ് ചെയ്യാൻ. Okay, so here the equation is solvable once you reduce it to the canonical form. So we will first see what is the canonical form and then we will see how to find the solution. So the equation can be written as r minus t equal to 0. So r is dou square z by dou x square and t is dou square z by dou y square. R minus t equal to 0 varum. So capital R is 1, s is 0 and t is minus 1. So s square minus 4rt will be equal to 4. So which is positive. So it is a hyperbolic equation. So it is in the form of case 1. അതായത് characteristic equation കണ്ടുപിടിക്കുക. characteristic equationന്റെ നമുക്ക് different roots കിട്ടും. characteristic equationന്റെ രണ്ട് solutions ആയിരിക്കും. That will be your required u and v values. So first of all, solving the quadratic equation. So you called as lambda quadratic equation. So that is r lambda square plus s lambda plus t equal to 0. But r s t substitute here, you will get lambda square minus 1 equal to 0. So roots will be 1 and minus 1. Appa characteristic equation is dy by dx plus lambda 1 equal to 0 and dy by dx plus lambda 2 equal to 0. So lambda 1 and lambda 2 substitute you will get dy by dx plus 1 equal to 0 and dy by dx minus 1 equal to 0. Then dy plus dx equal to 0 dy minus dx equal to 0. So integrating you will get y plus x equal to c1 and y minus x equal to c2. So you have in the form u equal to c1 and v equal to c2. So these are your u and v values. U y plus x v y minus x. You will get the same form at the end. Okay. Now this equation. So the first equation we have here, that's in variables x and y. Now we need to convert the entire equation in terms of u and v. So now by using chain rule, so P is dou z by dou x. So by chain rule you can write it as dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. Now from u and v, so dou u by dou x in the 1 verum, dou v by dou x is minus 1. So this will become dou z by dou u minus dou z by dou v. Now q is dou z by dou y. By chain rule I can write it as dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou y. So dou u by dou y no 1 verum, dou v by dou y 1 verum. So you will get dou z by dou u plus dou z by dou v. So that is P and Q. Next you need to find the equation that R and T. R is dou square z by dou x square, T dou square z by dou y square. So you can partial derivatives evaluate. Okay. So we need to find only R and T. R is dou by dou x of dou z by dou x. So that is dou by dou x of zu minus zv. This one. Okay. Now again use a chain rule. So by chain rule it will be dou by dou u of zu minus zv into dou u by dou x plus dou by dou v of zu minus zv into dou v by dou x. Now you know dou u by dou x and dou v by dou x. 1 minus 1 verum. So you will get, so dou by dou u of zu minus zv, that is z uu, then minus zvu, then minus of zuv minus zvv. So that will give zuv and zvu, they are equal, mixed partial derivatives. So I can write both in the order uv. So you will get zuu minus zuv plus zvv. Now next we need to find the value of t. But t is dou by dou y of dou z by dou y. So that is dou by dou y of zu plus zv. So again using chain rule you will get dou by dou u of zu plus zv into dou u by dou y plus dou by dou v of dou zu plus zv into dou v by dou y. Dou u by dou y, dou v by dou y 1 aanu. So this is zuu plus zvu, then zuv plus zvv. So that is again zuu, then 2 times zuv plus zvv. Now substitute r and t. So our equation is r minus t equal to 0. So that will give us, on substitution you will get minus 4 zuv equal to 0. So which gives zuv is equal to 0. So this is the required canonical form. So the canonical form is dou square z by dou v dou u equal to 0. This you can integrate and you can obtain the solution. Okay. So when you integrate, so first you integrate with, this is dou by dou v of dou z by dou u. first integrate with respect to v. Right hand side is 0 ആണ്. So when you integrate with respect to v, so you will get a constant. So constant will be in general a function of u. Dou z by dou u equal to phi of u വരും. ഇനി integrate again with respect to u. അപ്പോൾ phi 1 of u അതിൻ്റെ integral എടുക്കുമ്പോൾ again it will be a function of u itself. So I can write it as some f of u and the constant will be some function of v. So the solution is z equal to f of u plus g of v. So that is the required solution. So here we have reduced to canonical form and we have found out the solution in terms of the canonical form. Here you can substitute back u and v here. So u is y plus x and v is y minus x. So I haven't written that step. Please do complete that. So here the final solution is z equal to f of y plus x plus g of y minus x. So that is the final solution. So for the problem r minus t equal to 0.